ජයකොඩි ඉන්නවද?
Yeah.
මොකෝ එන්නේ? බේසික් ටික හරි ජයකොඩි?
Good afternoon all. So it seems like 27 participants are there. Right. Good afternoon. So welcome to fault diagnostic and rectifications of engine systems, lecture number 3. So I had received almost all the answer scripts for the actually quiz only. I still checked. I only checked the quiz. I have to check the assignments also. Please please make sure. I just have to clear this first before we go into the next. Before we start the class, when you are submitting the your quizzes or even if your assignment, you should only submit it to the Teams, Microsoft Teams only. Please do not send emails to my email addresses, either one of them, especially not the personal emails. Please don't send any unnecessary emails to that. I won't be checking. None of the email. I will not be accepting any of your answer scripts through emails. You have to submit it to through your Office 365. Microsoft Teams. Make sure to submit it through Microsoft Teams. Okay, right. So we discussed about the fault diagnostic basics, the first section, and what is fault diagnostic 6 steps method, and diagnostic on paper method. So since now you have some idea what is this diagnostic, what sort of diagnostic methods are available, next part is to move into the vehicle. So when it comes to the vehicle, you have so many components. There's so many components, so many systems. They are interconnected, they are working together, so they are harmonized. So you should be able to actually rectify almost all these components. But please bear in mind that this is actually something like this is more or less like I'm trying to teach you somewhat like I'm trying to teach you how to sing through online, something like that, because this is highly practical module. So even though we did not start any practical so far, the reason being is it's not exactly easy to teach this in practice, because when we go through this module, you will understand. Even though in the last even though in the last classroom, in the last class, you did not have any problem. Probably you didn't have any problem because you were just applying the theory part. Now we are moving into the more practical related or practical oriented component of the this subject. So this is your second section of the fault diagnostic and rectification of the engine systems, and this is going to be actually a little bit shorter than I actually anticipated, because mainly we don't have the practical components that we can't actually do the practicals online as we are expecting more, which we used to do in the classroom last semester. So don't worry about that. Once you come back to the faculty, I make sure to do the practicals, and whatever is possible to cover through the online will be covered through online practicals as well. Right, so today we are going to talk about mechanical diagnostic techniques. So as I discussed earlier, So you have so many components, so many things working together, systems to working together in order to make the vehicle move and safe to drive. So since there are a lot of components, all these components, uh, it's not possible for us to like teach the diagnostic technique for each and every component. For example, the cooling system diagnostics and techniques, and next we can't go to like a chassis system diagnostic technique. It's not possible, right? It is not possible. What we can actually teach you is mechanical diagnostic and electronic or electrical system diagnostic, because even though there are so many components and systems, each and every component system and component is actually comprises two parts, that's mechanical part and electronic part. So if you have a broad idea how to rectify the mechanicals and how to rectify the how to diagnose the electrical sections, then by combining these two you should be able to rectify any system, right? For example, again, if we took this, if we take the same example that we took last class, cooling system. So in the cooling system, what you used to do in the cooling system, there are so mechanical part being the uh, water pump and the engine, water pump, cooling jackets, radiator, all these hoses, and everything is actually mechanical components. But next you have the electronic component, the electric fan, the radiator fan, which is an electric system, but it has a sensor that connected into the engine block, which measure the voltage and then control a relay, which uh, in turn switch on or switch off the uh, cooling fan for the radiator. So in that you can actually see that mechanical part is there, electric part is there. So by combining both of them only, you will be able to understand or you will be able to diagnose. So what we are going to discuss today is mechanical diagnostic technique. So mechanical diagnostic is a little bit larger area compared to electric diagnostic, because mainly mechanical means it even though it's something you can actually see, it's not something you can actually measure that easily. But once you can go to the electronics, electrical and electronic diagnostic, even though you can't see the current, it's very easy to measure as long as you have the proper equipment. But in the mechanical diagnostic, getting the proper oh, the measuring equipment is quite difficult, because one thing is they are expensive, other thing is finding a fault through these components is a little bit hard. But fortunately, in the mechanical diagnostic, the former experience, the usual experience through gain through the use of the vehicles and by doing and more diagnostic can be actually used to diagnose another vehicle, right? So in the mechanical diagnostic, there are few things actually you need to understand in the mechanical diagnostic. For any diagnostic, first thing is check for obvious things being like leak fluids, loosen bolt. For example, if a person said came to a mechanic and said my right side wheel is making a noise, what is the first thing you should do? Check for the bearing? No, that's not the first thing you should do. First thing you should do is you should check whether the wheel or lug nuts, whether the lug nuts are tight enough. Then you can go to the noise, vibration, and harshness. We call them an NVH. So we have to check these things. So drivers are actually very much sensitive to these things, because our body, we mainly actually record this noise, vibration, and harshness part. So in these main affecting areas could be the tires, engine accessories, suspension, and drivetrain. Any problem in these things actually transfer to the driver or the occupants in the vehicle as either as a noise, vibration, or harshness. So So we will be discussing about each and every one of these things. But before we go into this, I just need to take a 1 minute to discuss about this noise, vibration, and harshness part, right? Noise, vibration, and harshness. So this section. So noise, vibration, and harshness is something very important in automobile. So if you very simple example, right? Now if you go and buy a vehicle nowadays, right, a brand new vehicle, and if you take a 20 years old vehicle, if you start to drive them, right, if you compare the driving as the driver, once you're sitting inside, what you can actually feel, the difference you will be feeling is actually comes to this NVH part, right? So NVH is a very important section, even though vehicles are, we were discussing that vehicles were changing every day, they were advancing this and that, but the thing is, vehicles were not changed that much, right? Vehicles were not changed that much. If you look at the first automobile that was built by Carl Benz, even though we have been using vehicles for around 100 years, still, even though we were using 100 vehicles for 100 years, still we are using the same recipe, right? Same basic layer for a vehicle. So same type of engine. There are some modifications or some advances happen in the engine, but still the same recipe, right? We didn't change a lot, right? So, but there's something we changed a lot is this NVH part. With the beginning of the century, or when the vehicles were introduced in 1900s, they didn't have grooves, they didn't have any sound definition, there's no wide suspension, so nothing was there. So then these things were added, little by little these things, this NVH part got very complicated and became a very important part. So the difference you are feeling in a new vehicle, right? Difference when you feel in a brand new vehicle and an old vehicle actually goes into this NVH part, right? NVH part. So then there's a specific module dedicated for this, to discuss about this part in your syllabus. You will be, I think, learning it in the seventh semester. Yeah, seventh semester. So since this is the most important part that we can feel, we can't actually feel anything happening inside unless it actually transferred into the driver component as one of these things, either noise, vibration, or harshness. Harshness being very rigid suspension, something like that, or knocking, that sort of things only we will actually be feeling. So so when it comes to noises, now noises, so in this mechanical diagnostic section, yeah, mechanical diagnostic section, we will be discussing on these three. So noise is one of the main things. So noise conditions do change with the type and the age of the vehicle, but generally it can be listed as below. Now that's an important thing, right? Let me explain why. So if you if you look at a vehicle made in 1980s and a vehicle made in 19 or 2000s, right? Let's say a car. Yes, let's take Toyota Corolla. Yes, very simple. A very common example. If you take a Toyota Corolla made in 2005 to the in 2005, and if you compare the same vehicle made in 1985, right? That's a 20 years gap. So between these 20 years gap, the vehicle's engine noise change, right? Body shape change. So since because of these changes, the noise will be actually changed. One of the main important thing is, if you look at the old vehicle, something like the 1985 Toyota Corolla, it has rubber seals going all around the wheels, all around the windows, right? That rubber strip goes around the windows. But if you look at a new vehicle, you can't actually see it. And you have water rails or iron, the gutters, yes. We call them as gutters in the roof. Also, you can see for the water flowing, those were there. But in the new vehicles, you can't see this. New vehicles, the body shape is so smooth, you can't see any obstruction for the airflow. The reason for doing this is when you are traveling through a high windy area, these rubber sealants and gaps, these openings and everything start to make noises, right? These are making noise. So by removing these things, by completely eliminating these parts, vehicles noise change, more noise will be actually reduced. But however, there are some noises that will not change. One is actually the gear noise. Now, typically gears do not actually make any noise. If the gearbox is actually working properly, it should not make any noises. But if the gearbox has any problem, for example, the gearbox worn out gearbox usually makes like a whining noise. So in case something like that, howling or whining noise, howling means something like a wolf is making noise, that's more or less like a howling noise. Whining means, you know what's whining mean, due to damage or incorrect bearing loads. So, and it could actually occur in different speeds and different driving conditions. Sometimes during the acceleration, because during the acceleration, more force is actually applied to the gear teeth. So as a result of that, it could actually generate a whining noise, but which will not come on in the other times. And another noise is chuckle, right? Chuckle is like a rattling noise, similar to like a, as mentioned here, sounds like a stick held against the spoke of a spinning bicycle wheels. Usually occurs while deceleration. Knocking is very simple to the chuckle noise, but it may occur louder and occurs in acceleration or deceleration. So these are three noises that actually mentions, even though the vehicle type and age may difference, these sort of a very common noises are still available, because even though vehicle body and shape change, the basic principle of the how the vehicle works will not change. So still they will be there. Next thing is actually the vibration condition. Clicking, popping, or grind is noticeable at low speeds, but caused by following inner or outer CV joints, often due to lack of lubrication. So check for speed gauges. So the vibrations could occur any of these reasons. So as mentioned here, CV joints, loose drive shaft, and other components contacting in the drive shaft. For example, exhaust pipe is contacting, and all the handbrake cables. Anything else? So loose bearing in the drive shaft, the carry bearing. Damage or incorrectly installed wheel bearing. So wheel bearing installing is a very tricky job. You need to add the correct preload in order to keep the wheel running without coming it out. So if you if it is incorrect properly, if it is installed incorrectly, it could actually create a vibration, or could even damage wheel bearings. Actually makes a lot of sense in this case. Brakes or suspension components. Brakes actually has a big issues. The brake start to wear out, especially in the disc brakes. They start to wear out, especially during the heat. Because of the heat, they start to warp. Warp means start to like create like a, what you call this, like a waveform, similar to a wave in the disc. So with these, with them, when you are applying the brakes, it actually start to create a vibration. Suspension components also could create a vibration, especially if they are worn out and if they are old, and or if the vehicle kept for a long time without running, suspension could get a little bit jumpy, creating a vibration. Some of the common reasons for vibration is out of balance wheels. This is one of the very common things, because especially in Sri Lanka, most people do not actually follow the correct procedures where whenever they actually replace the whenever they have replaced the new tires, you should actually always balance the wheels. That's actually very good for the health of your wheel bearings as well, but health of the wheel bearing and steering. So normal speed vibrations mostly come from the out of balance wheels, out of round tires. Now, out of round tires mostly caused by braking or kept by keeping a vehicle parked for a long time. That actually creates flat spot. If you apply hard brake without ABS, right? If you apply hard braking without ABS, since the vehicle the wheels will lock up. Since vehicle wheels tend to lock up, that lock up wheels will start to slip. So that rubbing against the wheel will actually remove a certain amount of rubber from the tire, causing out of round tires. Vibration during acceleration. So damage powertrain, drivetrain mounts. So that's a good, very simple. Oh, common thing. And excessively worn or damaged outboard or inboard CV joints. So whenever these things, what you have to understand here is whenever acceleration happens, whenever you accelerate the uh, vehicle apply or engine is applying higher torque into the through the drivetrain components, which could actually create a vibration. So there are methods you can actually isolate where the vibration is actually coming from. Very good method is following a road test. So road test is actually providing a good understanding about the vehicle's use. A proper road test should be performed before do any maintenance and after. Right. So doing before is to doing the before the maintenance is to make sure that vehicle make sure that vehicle is make sure that the the problem mentioned by the driver is actually is there, and to confirm whether the problem is actually coming from the specific component. And after maintenance is to make sure that the problem actually had gone away. If it is not had gone away, there may be something wrong. So you have to continue working on the vehicle until you take it or until you manage to find it out. So make sure to make sure to conduct a visual inspection prior to road test. So this is another important thing. So important thing means visual check is very important to find out any obvious problems that may cause or that may derail your judgment regarding the vehicle's condition. For example, tire pressures. Now, for example, tire pressure means if a vehicle owner came and said to you, whenever I'm driving, vehicle is actually tend to go to the left side, right? Vehicle is tend to go to the left side. So once he said that, you might be actually sending, okay, the main thing, first thing you may come, first thing you will, the first thing will come to your mind is that vehicle alignment is up. But before you go into the alignment or anything, first thing you should check is whether the tire pressures are okay. If the tire pressures are not okay, if the left and right wheels are having different tire pressures, that could actually cause for vehicle to push or vehicle to pull into one side. And leaking fluids, loose nut and bolts, as I told you earlier. Leaking fluid could, especially if someone said my gearbox is making a noise. Once you check underneath the vehicle, you should be, if you see the brake gearbox oil is actually leaking, that could actually indicate the gearbox is not actually having enough fluid. Rather than dismantling the gearbox, you could actually replace the fluid and see whether the noise is going away. If the noise is going away, probably it's fine. Unless the noise is going away, you may not have to be completely taking it apart. Loose nut and bolts again. My first example, uh, you driver said the left side wheel is making a noise. So before you check whether the wheel bearings or anything, first thing you should check is whether the loose nut or bolts are there. Any vibrations coming from the engine bay, you can check all the nuts and bolts are there. And bright spots where components may be rubbing against each other. One example, one person could actually, one driver replace his tires and he comes and say, okay, whenever I'm going, I hear a noise on the left rear wheel of my car. Then if you look at under the wheel arch, right under the wheel arch inside the wheel well, you may sometimes see a bright spot indicating that tire is actually rubbing against the wheel well. Right, check luggage compartment for unusual loads. That's also very important thing. If the vehicle is loaded unusually, that could create that there's a possibility that your suspension could create unnecessary create creaking, and um, that your suspension could create additional noises that usually it's not there. So, and another thing is, if the before you do any road test, you should also check whether the luggage is properly kept. If the luggage is flying here and there, sometimes you may actually accidentally thought a sound is coming from somewhere else, even though it's actually coming from the luggage of the vehicle. So see if you can connect any of these issues found during the road test with the visual inspection results. You could not move to the next phase. Next phase being dismantling the components. Right. So in the road test, there are a few things you can actually keep in your mind whenever you are doing a road test. You can actually test. One is normal driving speed of 20 to 80 kilometers. That's 15 to 50 mph. With light acceleration, a morning noise may be heard and possibly vibration is felt in the flow pan. It may get worse at certain engine speed of load. So it's not actually from the engine, it's actually coming from the flow pan. Acceleration, deacceleration. So acceleration and deacceleration, shake is sometimes noticed through the steering wheel and seats, front floor plan, door trim panels. High speed vibration may felt in the front floor pan or seats with no visible shake, but with accompanying sound or rumble, buzz, hum, drone, booming noise. Caused with the clutch pedal down or gear lever in neutral and engine idly. If the vibration is still evident, it may be related to the wheel, tires, front brakes, disc, wheel hubs, or wheel bearings. So one way to actually, this is one of the simple method that used to identify whether the voice or vibration is coming from the engine or whether it's coming from the drivetrain. So if you can actually disconnect the connection between engine and gearbox, you should be able to do that. So on the move, you can actually press the clutch pedal, or you could actually put the engine in gearbox into neutral position. As once you do that, if the vibration still coming from the vehicle, there's a possibility the vibration is actually coming from the drivetrain or chassis. But if since the engine is in idle condition, it's not coming. It's very highly unlikely to coming from the engine. If the even engine rev means sensitive, a vibration may felt whenever the engine reaches particular speed. It may disappear in neutral course. Operating the engine at the problem speed while vehicle stationary can duplicate. The vibration it can caused by any components from axis and drive wheel to clutch or torque converter, which turns at engine speed when the vehicle stops. So if your vibration is actually not coming from the drivetrain, still the vibration comes at certain speed, you can actually keep the park the vehicle and start and accelerate again at certain engine RPMs. Still the vibration may occur. In that case, you should be able to identify. So nothing to do with the drivetrain; it's mainly from the engine. So you can check anything related to engines. You can start from the front of the engine to the back of the engine. So front of the engine being belts and all the pulleys and belts, power steering pumps, water pumps, all these components, even the tappet covers, everything you can actually check. Sometimes if the if simple bolt might be sometimes a simple bolt might be used and a small cover may be actually vibrating. Noise and vibration while turning, clicking, popping, grinding noises may be due to following: CV damage, loose CV damage, front half shaft or boot. So that's mainly related to the front wheel steering and front wheel driving vehicle. So bearings, damaged drivetrains and powertrains and drivetrain mount. So again, so I'm just trying to explain some things you can actually identify in the road test. So during the road test, your main purpose is to make sure keep your while you're keeping your eye on the road, you should be able to identify where the sound, where the noise is actually coming from. Noise or vibration. So by conducting a simple test, something like pressing the clutch pedal or applying the brakes, you should be able to actually isolate where the problem is coming from. In this method, in this case, you can actually use usual uh, 6-step method to actually identify the problem. So if you, for some reason, if you did not able to confirm your problem, so you still sometimes you may actually able to found the problems, but you are not confirm which components which this problem is actually generated. In this case, you can actually bring the vehicle to a lift, two post or actually two post lift, and drive the vehicle while the vehicle is on the lift, right? While the vehicle is on the lift, to find out what's the problem. So this is not actually something recommended. You can do it, you should do it, but it's not the best thing to do. The best thing to do, being since the vehicle is out of the ground and wheels are at their highest suspension position, so it's not the best way to find out problems if it is something to do with suspension. So that being said, some precautions could actually be used. One of them is you should not actually drive the vehicle over 55 kilometers per hour. During, if you try to accelerate over that, it could actually create too much vibrations that your low lift could not actually withstand. And steerage joint should not be operated at high speeds at high angle, as it could be damaged. As I told you earlier, since the vehicle is at its highest suspension position, so your vehicle wheels are suspending from the air. So that's actually at the highest position they can, highest suspension position they can go. So there's a possibility you may actually damage the CV joint. So it's not exactly recommended thing to do. And the second thing is that another important thing, test on the lift may produce different vibrations from the road test. Then you should be able to distinguish the difference between them, these two, and identify the issue in hand. Usually, suspension components generate vibrations in such cases as they are suspended on air, right? So as they are suspended in the air, because that's the maximum suspension position, there's a possibility they will create additional noises, something not usually, something unusual noise that you will not be able to hear while you are driving. Okay, so next part is engine noises. So engines are complicated and important, and in engines it's very difficult to find out where the fault is. Thanks to now, but thanks to the systems now we have, actually there's a possibility we can actually find out where the problem actually comes from. So engine noises could not be explained theoretically. That's the main thing. It's not possible to explain it theoretically. Someone's mic is on. Whose mic is on? Okay. So, but even though they are not like a something theoretically can be explained, they are by doing these diagnostic for a long time, and based on the noises coming from the engines, there's a possible sources can be actually listed out. So as mentioned here, right, noise description and possible sources. One, starting with the tap noise. Usually the tap noise is actually comes from the valve clearance out of adjustment, cam follows and cam lows bone. So this is a very simple and very common thing. If the vehicle is not properly maintained, these start to generate noises by repair, just by just by adjusting them. Then this noise will actually go off. Rattle, loose components, broken piston or ring component, something a little bit serious. A loose component be, for example, a loose tappet cover could actually generate a noise like this. Even a timing belt cover could actually generate a such noise. Once again, hello. Oh. Petrol shed එක පාරේ එන්න ඕනි. petrol shed එක පාරේ ඉස්සරහට එනකොට නාපාන ඉස්කෝලේ දන්නවද? petrol shed එක පාරේ මේ අමුණුගම පැත්තට එනකොට තියෙනවා මේ අලු ට්‍රාන්ස්ෆෝමර් එකක් තියෙනවා වම් අත පැත්තේ. ඔව්. ඒ කියන්නේ අමුණුගම ආංජනේ කිව්වොත් ඒක හරිද? නෑ ඊට ගොඩක් මෙහා මේ ඉතරම් මෙහා. ඔව් මේ ෂෙඩ් එකේ ඉඳන් කිලෝමීටරයක් ඈ? ඔව් වීමෝල පහුවෙලා චුට්ටක් ඉස්සරහට එන්න ඕනේ. මම ඒ නෙවෙයි තව ඇතුළට එන්න ඕනේ එතනින්. මට දැන් නම් ඇත්තටම එන්න විදියකුත් නැහැ. ඔව්. ඒක ඇතුළ පාරකට යන්න ඕනේ. ඔව් එතනින් ඒක වීමෝල පහුවෙලා තව ඉස්සරහට එන්න ඕනේ. එතකොට ට්‍රාන්ස්ෆෝමර් එකක් තියෙනවා. පාර කෙලින් වුණාට පස්සේ ට්‍රාන්ස්ෆෝමර් එක තියෙනවා. වංගු දෙකක් විතර හැරුණාම පාර කෙලින් පේනවා. එතනින් වම් පැත්තට ට්‍රාන්ස්ෆෝමර් එකක් තියෙනවා. ඒ ට්‍රාන්ස්ෆෝමර් එක දිගේ තව කිලෝමීටරයක් විතර එන්න ඕනේ. කිලෝමීටර නැහැ මීටර 500ක් වගේ. මේ ඒ ඇතුළට පාර දැම්මම කාපට් පාර තියෙන්නේ. ඒකෙන් කොහෙටවත් හැරෙන්නේ නැතුව ඒ පාර දිගට ආවම පල්ලමක් තියෙනවා. පල්ලමේ උඩ ඉඳන් දකුණු අත පැත්තේ 4 වෙනි ගෙදර කළු පාට ගේට්ටුවක් දාලා තියෙනවා. වාහන දෙකක් නවත්තලා ඇති මිදුලේ. ඔව් ඒක දිගට එනකොට ඔව් ඇතුළට දාන්න ඕනේ. ඒකේ දිගටම එන්න ඕනේ. ඒකේ දිගට Oh, ඉස්කෝලයක් කැම තියෙනවා ඒ ටික පව් කරන් එන්න ඕනේ. ඒකේ ඇවිල්ලා ඒකේ පල්ලමක් එනවා. ඒ කියන්නේ ඒ කාපට් පාරද කියනකොට පල්ලමක් හම්බ වෙනවා ලොකු. ඔව් කාපට් එකේ ගියම එන්න. ඔව් ඒ ටික පව් කරන්න තව එන්න ඉස්සරහට. වංගුවක් ඇති ටිකක් ලොකු. පොඩි කන්දක් තියෙනවා ඒකත් එක්කම පල්ලම. ඔව් උරදෙනි පැත්තට වැඩේ. පල්ලමේ 4 වෙනි ගෙදර. කළු පාට ගේට්ටුවක් දාලා තියෙන ගෙදර. දකුණු අත පැත්තේ. ඕමින් මම පාරයින්ද. Right. Sorry about that. Right. Rattle could actually generate from a loose components or broken piston ring or component. So, but here, please understand this thing. The first mentioned possible source is the most common thing, and secondly mentioned thing is the least possible reason for this noise description given here. So next one is light knock, small end bearing worn out, or a cam follower warning. Cam follower warning. If they are worn out, a knock could actually generate a deep knock or thud. Big end bearings worn, rumble, main bearings worn out. Main bearings being the crankshaft bearing. Slab piston, worn pistons or bore. If the bore or the piston is worn out, that means the piston is running in essentially a larger diameter hole than it's actually designed. So it actually moves side to side, creating a slapping noise. So similarly, vibrations, loose or out of balance components, clatter, broken rocker shaft or broken piston rings, hiss, leak from inlet or exhaust manifolds, which we will be actually using this hissing noise to rectify small issues in the engines. I will explain in the practicals. Roar, intake, air intake noise, air filtering, air filter missing, exhaust blowing or ceased viscous fan drive, right? So viscous fan drive means that viscous fan means the your radiator fan. Clunk, loose flywheel, worm, thrust, bearings, or loose front pulley, damp. Winding, power steering pump or alternator bearing, which is a very common thing most of the time. If your alternator is not charging properly, it could be the reason. Shriek, dry bearing and auxiliary components, squeal, slip dry bears, very common things. So since these are basically you need to actually remember these things. I can't exactly say by just remembering these things. You when you hear a certain noise similar to this, you could actually uh, yeah, you could actually assume that this may be the reasons and start doing your test to confirm these issues. So right, so engine noises and causes, since we have discussed certain cause noises, if these causes have if these noises have causes, and you need to actually come up with the rectification, no possible solutions for these issues. So one good example here is misfiring or backfiring. Now in this again you have to remember these possible causes are actually mentioned on the order that could actually happen. So for example, if we take here misfiring or backfiring, fuel in the tank has the wrong octane cetane number. If the wrong octane cetane number during the engine, if this having the wrong octane or cetane number, the compression during the compression engine start to actually misfire, right? So as a result of that, it could actually happen, or faulty ignition system, right? Fault ignition system or engine temperature too high. For some reason, if the engine oil is not cooling properly, it could actually generate high enough temperatures inside the combustion chamber, especially inside the combustion chamber, creating misfiring actually. Carbon deposits in the combustion chamber start to glow and cause misfiring. That's actually happens because of the if the engine is too old, and if the engine since the engine is too old, when you are running it for a long time, the carbon deposits start to generate heat and it will actually combust the air fuel mixture. Timing incorrect, which cause misfiring and the intake exhaust system. This is possible. Now if you look at here, consider these possible causes. Third one, timing incorrect, is the least possible cause, because timing belt or chain is actually driven in a sprocket, in a toothed wheel or a sprocket wheel. So there's like a very small chance that could actually miss a teeth or a sprocket, but it is possible. It is possible, but the least possible scenario in this so problem. So for each one, you have some solution here. For ignition system problems, you can actually check the ignition system. So you need to know what are the ignition system tests, and if the engine is temperature, engine temperature is too high, you should be able to find out from a oil pressure test. If the oil pressure, when the engine temperature is getting too high, oil pressure start to lose its pressure. And remove carbon deposit by using fuel additives and driving the vehicle carefully. And if the timing is the problem, check the timing. So if there's a misfiring cause, you can start from the first one, and you can actually advance through each and every other solution given here. So valve train faulty, valve clearance too large. So possible causes could be valve train, valve clearance too large due to faulty bucket tappets, or incorrect adjustment of the valve clearance. So in such cases, you can actually adjust the valve clearance and possibly renew faulty buckets again. Do the valve clearance. And valve timing incorrectly adjusted. Valves and pistons are touching. Timing belts broken or damaged. Check the valve timing and adjust necessary. So again, next one is engine component faulty. You can actually go through this when you actually when you read in this, you should be able to understand, because you guys have enough knowledge on what are the components in the engine, what are the components need adjustments, what could actually go wrong. So please go through this. I will just next part also. Yeah, I will just go through this very fast. Engine components faulty piston rings, engine block, gasket, big end of main engine burner journal. So if you have some problem how the piston ring, we can actually find out. There's a small practical we will be performing in our engines that we have. Auxiliary components, engine components, auxiliary components, loose or broken. So check components, secure, tight, adjust, tightening, yes. Right, so that's it actually for today. Uh, Based on this, there's a small, actually small, there's a practical we should be able to do. I will actually let you know when we are doing practical. Please, I will send you a small activity to do related to this module. Please complete that and submit it according to the instruction given in the document. So I know this is not the most ideal place for teaching this sort of a module, but considering the prevailing situation of the country, and this is the only option so far we have. So we'll try to make the best out of this. I will let you know about the practical times and everything. Okay, thank you very much.